Question number 4 in here states that there are many other types of numbers, which we already know. They can be whole numbers, natural numbers, they can be real numbers, even, odd. But apart from that, we are having different other types of numbers as well. So we have to find out these numbers and give an example of each. The three that are mentioned to us, these are the perfect numbers, palindromic numbers, and narcissistic numbers. So we will try to understand what type of numbers each one of them are. So taking a start with the perfect numbers, we define perfect numbers as the number that is a positive integer. It is a positive integer whose proper factor, in here I'm using a term proper factor, adds up exactly to the number itself, or we can say that the sum of its factors is equal to the number itself. Now in here we also need to know what is meant by factor. We define factor as a number which is a whole number that divides the number exactly, leaving no remainder. Or we can say factors are number that can be multiplied together to make a given number. Let's say we take the example of 6. So the factors of 6 are those numbers that divide 6 exactly without leaving a remainder. Or it can be those numbers that multiply together and give us this number 6. So 6 in here, if we take the factors of 6 are 1, 2, 3, and 6 itself. But in perfect numbers, we used term proper factors. So proper factors mean that the number itself is not included in the factors. So 1, 2, and 3, these are the factors of 6, and when we add them, that is sum of its factor. So 1 plus 2 plus 3, and we get 6. So the sum of its factors is equal to the number itself. When we add the factors of that number, which is in this case, or in this example, 6, it gives us the number itself. Another example can be the number 28. So those numbers that completely divide 28, or that can be multiplied together to give us the number 28, these are 1, 2, 4, 7, and 14. Again, we are considering the proper factors. So if we add them, so 1 plus 2 plus 4 plus 7 plus 14. So when you add them, 7 plus 3, 10, 10 plus 4 is equal to 14, 14 plus 14 is equal to 28. So again, when we add the factors, the proper factors, it gives us the number itself. Another example is 496. The factors are, it has kind of a little bit longer factors, large number of factors, which is 1, 2, 4, 8, 16, 31, 62, 124, and 248. So when you add them all, we get 496. Another example is 8128. Its factors are 1, 2, 4, 8, 16, 32, 64, 127, 254, 508, 1016, 2032, and 4064. So adding them all, when we add them, you will get 8128. So these factors, when the factors are added together, they give us the number itself. Apart from that, we are having other perfect numbers as well, but they are very large, they are very big numbers. For example, what are they? These perfect numbers can be, let me write it somewhere in the corner, perhaps in the end. In here we are having 33, 50, 550, and 336. Then we have 8, 5, 8, 9, 8, 69, 0, 56. And next we are having 137, 438, 691, 328, and this one is very big. It is 2305, 84, 3008, 139, 952, 128. So you know these are very big, large numbers, which are an example of perfect number. I hope it's all clear to you now. The palindromic number, these are the easiest one. Palindromic, same forward and backward. When we read them, reading from forward or reading from backward, it is the same. What do we mean by that? For example, we are having 1, 2, 1. So reading it forward or from the backward, it is read the same. It is the same number. Or let's say we do 343. Or let's say we do 404, 525. So you see, it is forward and backward are the same. Narcissistic numbers, in other words, the number that love themselves, these are the numbers. We can define them as it's sum of the digits raised to the number of digits. Before trying to understand that, let me give you one point, that all single numbers are narcissistic numbers. So let's say I say 1. So there is one number. So digit raised to the number of digits. So there is 1. 1 raised to the power of 1 is equal to 1. 2 raised to the power of 1 is equal to 2. 3 raised to the power of 1 is equal to 3. So all the single numbers are narcissistic numbers because there is one number, and one number raised to the number of digits because there is one digit. So raised to the power of that one give us the number itself back again. So therefore all the single numbers are the narcissistic numbers. Now coming to the 2 digits, there is a fun fact that we do not have any 2-digit number that is narcissistic. It can be 1 digit, 3-digit, or 4-digit number. For now, we will consider till 4. So for 3-digit, it can be, let's say, 370, or 371, or 407. These are all the narcissistic number, because if you add them to the and raise them to the power of the to the power of the number of digits, it will give us the same number. There is one other number, 153. So what do we mean by that? It means that we have 3 digits, right? So 1 raised to the power of 3 plus 5 raised to the power of 3 plus 3 raised to the power of 3. So it is the sum of digits, these digits in this number, raised to the number of digits. So the sum of digits and raised to the power of digits, raised to the number of digits. In here we are having 3 digits. We take the sum of it and raise them to the number of digits. So in here it gets 1 plus 125 plus 27. So when we add them together, we get 153. We also have 4-digit narcissistic numbers. These 4 digits can be, let's say, 1, 6, 34, 8208, 9474. I will try to explain this one or show you this one. So let's say we are having four numbers. 1634 is equal to 1 raised to the power of 4 plus 6 raised to the power of 4 plus 3 raised to the power of 4 plus 4 raised to the power of 4. So 1 raised to the power of 4 is 1, 6 raised to the power of 4 is 1296, 3 raised to the power of 4 is 81, and 4 raised to the power of 4 is 256. So when you add them together, we get 1634. So it's the sum of the digits raised to the number of digits. This gave us the narcissistic number. That was all for now. I hope it has been clear. Happy learning.